Okay, fluids 26. I don't understand how the value of Q2 was determined. I understand that each pump is 1500 over 3 equals 500 GPM each because the pumps are in parallel. But why isn't Q2 also 500 GPM? How did it become 750 GPM? This one was a parallel piping arrangement. And there were 3 pumps in parallel. Being fed by a common header. So there'd be a common supply header, a common discharge header. Let this be the supply, let this be the discharge. So we're pumping to the right. And it was a 2+1 redundant, N+1 redundant operation, such that, and the total volume flow rate was 1500 GPM. So you said in the problem statement, you understand that since there's 3, they're going to split the volume flow rate equally, and they're going to be 500 GPM each. And your question is, why is Q2, in other words, the volume flow rate per pump after the failure, because we're going to have one pump fail, how does that become 750? Well, if one of these goes away, the volume flow rate is non-negotiable, right? There's a certain amount of water flow that's required to satisfy the cooling loads. So now we're down to N, we're non-redundant, we need both pumps to run, and we still need 1500 GPM, but we need it across 2 pumps. So now we still have that same 1500, but it's only being divided by 2. So that's how we get 750. And it actually says in the problem statement as well, when one pump fails, the others speed up to provide consistent, uninterrupted flow to the cooling loads. So by consistent flow, we mean a consistent volume flow rate, which means we still have to get that 1500 total. We can't just accept that one has gone away, therefore we're going to get less flow. That's not the idea here. And if you think about why that has to be the case and how a hydronic system works, just downstream of this is some cooling loads that need to be satisfied. We have the cooling rule of thumb, 500 GPM delta T. So the load is the load is the load that has to get satisfied. So this is a hard requirement, no negotiating there. If the GPM is going to be lower, then the delta T is going to have to be higher. And we don't have any reason to believe that we're allowed to mess around with the temperatures here. Maybe the chiller's maxed out. Maybe it's doing all it can. So we're not being specifically told that we can take a 10-degree delta T and make it 30% or 50% larger. So in the absence of that, we have to assume that that needs to be held constant as well, which means we can't have a lower GPM. So hopefully that answers the question. I think I thought that one was pretty clear in the problem statement, but if it was still confusing, then let me know if that doesn't address it.